Hi, I'm Paul Brodie. This is my shop. Mitch is behind the camera as usual. Welcome. Today we're going to work on Aermacchi race brake for my vintage road racer. I've assembled some parts here. We've got a hub. This hub is off a Honda 450. This is the same kind of hub I used back in 2001 when I built my bike. Back in 2001, I got a hub off a friend for 35 bucks. I realize now that was a great deal because I got this off eBay, and by the time it was landed and I paid taxes and duty and all that, it was about 500 bucks. This is off a 1968 Honda 450 twin. And I happen to like this because of the size and the look. So what we're going to do is we're going to make some holes. You can see how I've marked out one hole. There's going to be 6 holes around here because on the inside we've got 6 ribs. So the holes are going to go in between the ribs, 6 of them. We've got a backing plate. This is what holds the brake shoes. The brake shoes go in here. I've got Frodo linings I've had sitting around for years. These are hard to find now. These are the race linings. They're green. They're made in England. I think they have asbestos in them. Better put it down. And the backing plate is going to get highly modified. It's going to have added pieces on it. It's going to get rotated. And what we're going to start out with is the torque stay. This is what holds the backing plate onto the fork. So this is the template that I had from 2001, and I've marked it out. So the first thing we're going to do is go over to the drill press. I'm going to drill a series of holes, knock out the middle, put it back in the mill, because now I can still hold this because these sides here are parallel, and I can take an end mill and I can make that smooth, then filing, and that's when I cut the outside out. So first of all, we'll go over to the drill press. Okay, I've got a 2-pound hammer. Let's see what happens. There it goes. That's what I wanted. So that just makes it a little easier. So we'll go back to the mill now, and I'll maybe use a 1/2-inch end mill, and I'll go along to the line. I'll put on some cutting oil now so that it's on there and I don't have to add much as I go. I'll switch to a little 1/4 carbide end mill. It's a 4 flute. There are 2 flute, 4 flute, maybe more, but that's the common ones. So we'll go faster now. We'll go up to 2,000 RPM. Okay, so that's the basic shape. It's not real smooth, but it's close. So we'll go to the bench vise now. Do a little bit of filing, not too much, but a little. Got a 1/2 round file here. It's a little bit coarse. Got my deburring tool. It swivels. I'm going to make the inside smoother later. You get the idea now what I'm doing though. Okay, let's go to the drill press. We need 4 8mm holes. I'm going to drill a smaller hole first and then I'll finish off with the 8mm. That's usually better than just going right from the center drill up to 8mm. So I've got something here on the other side. Drill. I can drill in metric too. It doesn't have to be imperial. Next step is the bandsaw. We're gonna make the outline over on the bandsaw. We've got a red line and we've also got a scribe line, and the scribe line was made by a pair of dividers, and so the scribe line is more accurate because it went off the center punch hole and the red line went off the cardboard template. So if you think that I'm following the red line and not doing a good job, that's not what's going on. There's a scribe line I'm following. I like that shape. Let's go do a little filing and then we'll move on to the hub. I'm using my father's old wood file. See, wood file. On aluminum, it works just fine. Also, when you're filing, you can see how straight you cut with the bandsaw. If you've got a lot of highs and lows, it means that you didn't follow the line very well. So, this is not bad. I've had a little practice. So I'm filing a radius. So this has a large radius here, but this is fairly flat, so I'll start filing around here. And once again, I'm going away from the radius. Okay, so now I'm connecting that flat with this flat. Okay. I'm just going to knock off the burrs now. I'll use a small file. It just takes off any sharp spots so I don't cut my hands if I'm going to handle it. This is just a little bit of used Scotch-Brite. So after it's all polished up, after the edges are all smoothed up, I think it's going to look quite nice on the bike. I'm excited about building a race bike. Okay, so next stage is to go over to the mill. We've got to set up the rotary table, angle the head a little bit, and we're going to drill holes in the hub to save weight. Maybe what we'll do first of all is to weigh the hub, and then we know how much metal we take off, how much weight saving. Let's do that. Okay, it's weigh-in time, and the hub is 2,873 grams. Let's go save some weight. I've got an axle here. It's a 15mm axle which fits the hub, and I welded on a boss, and the boss goes into the rotary table. Can you see how it fits into the rotary table like that? And then I've got a 6mm Allen screw that goes in from the back. So now, right in the middle of the table, I got a 15mm axle. So that's what I use to mount the hub. And then the hub is concentric. That's a good thing. I've got this marked with a felt pen, but that's just by eyeball when I came over the top. See how I've got a felt pen mark there? And then I kind of went over here by eye. And then it went up to the middle by eye. But I would like it to be right in the middle of these. So I think what I'm going to do is I'm going to drill a hole right down through the center of that rib, and then it's just got to be a really small hole, and then I'll know the exact center, and then I can line up off that. There we go. I'm going to see if I can drill a hole right there. There we go, we're through. Okay, so look, my line was pretty close to the center, but now I know where the center is. So the first thing we're going to do is we're going to drill 6 holes with a 1 5/16" hole saw, and then we'll use the boring mill, or the boring head, and we'll make a nice cut, because this doesn't make a nice cut. It cuts, but it's kind of rough. That's about 8 degrees right there, and I can see a little bit of space over on that side. If I put that up, it's pretty close. So it needs to go just a little more. That's 9 degrees right there. Can you see it looks pretty flat with the surface? I'm going to set my scale here to 0. Because we got 6 holes, so 6 holes means every 60 degrees. It actually makes a nice cut. It's an almost brand new hole saw, but I am going to go a little bit wider than that anyway. That's the first hole, so we go 60 degrees now. Every 60 degrees, because we wanted to do 6 holes. Going to swap tools now. We'll use a boring bar, open the holes up just a little bit more. Can you see how it's moving out? It's a pretty neat tool. And the scale is in thousandths. It is not metric, just in case you were wondering. So if I look at the spacing now, what I got to do is to line it. See how there's more space over here than here? So I need to bring the table this way. I need to move the tool out. Okay, a bit more. Okay, see how it's hitting? It's taking a little cut off the back there and nothing off here. So I'll move the tool a little bit. Okay, so we are basically centered, you know, within a couple thou. So. And we have to, you can see how much it's going to cut all around. Let's take a cut and see what happens. Okay, okay, I'm going to do something. You can see how it's vibrating. You can see how it's offset and it's out of balance. So what I do for that, I take this, it's just an extra piece of metal, and I put it here, and that's my counterweight. But what I have to make sure is that it looks like it's just going to clear. It's just going to miss. I have to keep an eye on that. Make sure that it doesn't move out. So I put an extra Allen screw in there. So that's my counterweight. So it should be smoother now. So as I go down, it is going to get closer there. I'll listen for any noises there. So that's smoother. And that's cutting nicely. Okay. And so the noise you hear there, that sort of a tapping noise, that's where it, see, can you see here, that little piece of casting that hangs down? That's the noise as it's hitting that. That's an interrupted cut. And we did not hit. So now we're going to go 60 degrees, and we'll do this 5 more times. Our next step is to drill a smaller hole in between the spoke holes. So it's a 40 hole pattern, so each side has 20. So that means I need to mark a piece of paper or cardboard every 18 degrees so that when I move the rotary table, I know what 18 is each time. I find the middle. It's right about there. You can mark like that. So that's the size of my drill. So let's just find, look at that, that fits pretty nicely right there. So let's see where we want this. This is very, very precise what we're doing here. So that's where we're going to put the hole. And it's a short drill, so it's not going to flex. So what I'm hoping is that we don't have to do a center drill, a pilot hole, and then that drill, because this is every 18 degrees. So we're going to set this up now, and I'm hoping that one drill goes right through. I took a piece of cardboard and I took my phone, my calculator, and I marked out every 18 degrees. So I'm going to look at this and I have to move the rotary table for every hole. That's why I only want to do this once, because otherwise it just takes longer. So what I'm doing now is to reposition. It's kind of an eyeball thing. It's just a lightning hole. If I touch down lightly with the drill, we're going to see how we're centered. I'll go a little faster. There you go. So that looks. So let's take a chance. Let's drill one hole, and we'll see what happens. Oh, that worked fine, and it's not hitting any shoulder or anything. It just goes through. Okay, we're rolling then. So we're going to go to 18 degrees now. And that should be right in the middle again. That was the 90, so 108. This is the last hole on this side. Excellent. I think that looks great. So now we have to do the other side, so I need to mark it, and then this one won't be held the same way because it's different. So we'll have to see what's going to go on here. Okay, so we're on 0, that's good. It looks like it's in the middle. Okay. Excellent. No screw-ups. I want to know how much it weighs. I'm very, very curious. So 2,716. So we have saved 100.47. 157 grams, so pound, well, it's less than half a pound, but anyway. And that's unsprung weight, it's rotational mass, so it all matters. I like the looks of that. That's a good looking hub. We had planned to do more filming, but we have a windstorm and a tree fell down and we lost our power. So we'll have to continue next week. But thank you for watching. Have a great week and stay safe. Thank you.